Hi, so what I'm going to talk about is a program I wrote called Bubble Breaker Solver, and I wanted to write a program that would actually play the puzzle for me and get me good high scores, or get me the maximum score possible for a grid. I've written a program in Java which is freely available on sourceforge.net. If you just search for Bubble Breaker Solver, I'll try and remember to put a link in the sidebar of YouTube as well. It's open source, so you can have a look at the source. It's an interesting computer problem. This, as well as actually solving the puzzle, it actually allows you to play the puzzle as well. So in this video I'm going to talk about where to get it, how to get it running on your computer, how to use it to play games and edit games, and how to use it to solve games for high scores. So let's get started. So when you go to sourceforge.net, what's going to happen is you're going to download a file from my project called bubblebreakersolver.zip. You can put this file and extract the file to wherever you want on your computer. So I've just put it on my desktop. If we go into the folder, which will be called just Bubble Breaker Solver, which I've already extracted previously. Here it is. So what you'll get in there is if you just want to run the program, you'll get a dist folder. If you go into there, you get a jar file. Now you can just double click on the jar file. However, if you want the output messages, I don't know where they go to if you do that. So the best way to do it is to run the command line, the Windows command line, and then if you can get the path to the file here, to the jar file. If you just cd to that path, just cd to that directory, and then just type java -jar bubblebreakersolver.jar. So just use Java to open that jar file, or to run that jar file, and it just starts it up. The first thing you can do is play the game. Now, that's what it does by default. It generates you a new puzzle, 16 rows by 11 columns, and it'll allow you to play it. So you just start clicking and solving the puzzle, and it keeps track of your score, and eventually you'll have no bubbles left and it'll tell you the game's over. In which case you can just start a new one and generate a new random game. The only thing that this program does at the moment, although it shouldn't be too much of a big deal to get to do more in the future, it only does the shifter methods. So as you can see, when I'm popping bubbles, as well as the rows falling down, the columns are moving right as well to fill up any free space. So it's down followed by right is the method that it uses for shifter, so you can keep playing the game. We've got some other controls over here. This is just a nice pie chart of the distribution. There's some controls here that I'll talk about in a bit, but just to play the game you don't need to worry anything about it apart from the score. It shows you your score here, and obviously as you highlight a potential cluster, it shows you the score for that as well. You can change, it doesn't have to be 11 by 16, you can change it to anything else that you want within reason. So if I want a smaller grid, I'll say 8 by 7, for example, you can generate an 8 by 7 grid. The little dots there, or if I make it sufficiently small that it fits on the screen, you can actually see the coordinates of each bubble. You can, as well as playing games, you can open games and save them. If I wanted to save the game at any stage, I can just file save game and just save it to a file on your computer, and you can open that game to resume it later. It won't work, it'll throw an error if you have changed the dimensions in between saving a game and opening a game. So in other words, if you save a game that was 4 by 3 and you set dimensions back to 16 by 11, which is the default, or 11 by 16 I guess I should say, then if you try to open that 4 by 3 game, the program will error. I haven't really fixed that yet. You can also edit games. So you can clear the grid and start putting in, if you go click mode, instead of play, you just go edit. You can select what colour you want each bubble cell to be, where to put the red ones, where to put the purple ones, etc. You can also you can explicitly in this mode also say clear that cell by selecting this one down here, which for some reason at the moment says blue, but it should say empty. But it's clear the grid. Set up some cells using the method edit. When I've set up enough, when I have at least one of each colour present, then I can switch to a slightly quicker method. Alright, so what I can do then is say edit by copy, and that means that when I click on the green, the selected colour automatically becomes green. When I click on the yellow, you can see the selected colour automatically becomes yellow, and then I can just clone rather than having to. So I just click on it on the same colour, and I can just sort of clone around the board. I can't click on the empty one using that method using the edit by copy. If I want to make some cells empty, I have to use the edit method. So using a combination of the two should get you going pretty quickly. So the next thing, the more interesting thing then, is how to solve it. To solve it, we've got a variety of options. For smaller grids, if I make this 5 by 6, I can make it what's called an exhaustive search, and that will. There may be bugs in this, but in theory, if I press the solve button and I look at the output in the command line, it takes a few seconds for smaller grids, and it takes longer and longer exponentially for larger grids. It's found me a score of 202 for that grid, and that's including the bonus I get for clearing the grid or partially clearing it. So and to find out what it did for the best solution, what it does then is in this box here it puts the coordinates automatically, although I can copy them out of the command line if I want to, and put it in to find something else that it did, but it puts them in, and so I just press the play course button over and over to see how it played that game to get the score it did. And you can find it actually cleared it. For large grids that's actually impractical. For large grids, if I was to try and say solve exhaustive, that would take literally almost forever. There's one other little silly one called random. If I set it to that and then select solve, what it'll do is it'll try 50,000 times. It'll just play random moves until there are no bubbles left, and it'll play that 50,000 times. So it's nearly there now. It's done 30,000, 36,000. It's only got a few more left to do, so we'll just let it finish. And again, once it's finished, it'll put the coordinates for the maximum score it's got, which is 1202 in this case, into the box, and we can keep pressing that button to see what it did. And you can obviously press it more slowly to figure out what it's actually doing, but the random one isn't that interesting. The much more interesting one, if we start a new game again, these are new random games, remember, is there are all these what's called fitness functions here. So all these the ones that are listed score underscore something, are all different fitness functions that allow it to search a tree of possible games more efficiently than an exhaustive search. However, it's not guaranteed to find the absolute top score, and it's about writing good fitness functions. The best one I've found is what's called score all clusters, and you can look at the code to see how that works, but there are a variety of other ones as well. I'm still working on a good fitness function, so I'm trying to improve it. For the fitness function, basically what it's doing is it's applying all the possible moves to the grid, and then for each grid that you're left with after applying them, it applies all the possible moves again. Now at some stage, obviously you're going to get a huge amount of grids that it has to remember in memory, so what it does, if after each generation of moves the number of grids is greater than X, then prune the tree back to X based on the best grids that it estimates, and that's what the fitness function is. It's the scoring function it uses to make a decision on which grids to keep. So score all clusters, you'll have to look at the code to see what that does, but that's the best one. 200 seems to be about the best size. If you made that bigger, then it means it keeps more in memory each time and it doesn't prune it as heavily. However, I found that in some cases, if you actually increase that, it can actually make the eventual score worse. 200 seems to be a good set, and just leave it alone too. So let's just go and press solve that. You can see the output here. It'll probably take about a minute to solve a 16 by 11 grid using the score all clusters method, which I think is reasonable, especially when you consider that it achieves quite good scores. It's almost impossible to find the maximum score, although I will keep trying to improve the fitness function. So we've got a score of 2216. If we just play it coordinates to see what it did, it probably did something different than what I would have done, but it's interesting to see what it did. What it seems to be doing is building up the green for the moment, but it will take those green earlier than you expect, and then it builds up a new colour. That's what I've kind of seen it do. And these are things that a human wouldn't necessarily do, but they can still lead to very good scores. So it seems to be concentrating on the yellow at the moment. Okay, it's taking that yellow now. It'll probably do one more sort of fairly large cluster, and then it'll just be tidying up the bits and pieces. Maybe the purple one there. That's going to be a pretty big purple cluster. I'll keep pressing the play coords button because it's automatically filled in the coordinates area for me. And actually it's going to solve this, and it's, as well as getting a good score, it's going to actually complete the grid. So if you want to look at the source as well, the source is in the zip file that you download, and it's a NetBeans project, and that's pretty much it. So hopefully you can have a look at source code, email me or contact me about any ideas, or just contribute to the project directly in SourceForge. And happy bubble breaking.